Here we have the first mock-up of the chamber that will have the intercooler core mounted on top here. As you can see, the throttle body's down the bottom with that plate that I've already welded on. There's just a little bit too much angle on this, with the result that the intercooler actually leans forward a little bit more than ideal. So I'll trim that back and try again. Alright, got the plenum chamber dummied up with the stubs that go into the throttle bodies slightly curved to fit in the bike and get the intercooler core at the right angle. So it's come out pretty good, pretty much as I wanted. Quite happy with it. So just got the other side to do, and then the top tank as well. Yeah, I might even fabricate this side up first so I can make absolutely sure of where it's going and how it's going to fit, and then do the other side. So could make it out of cardboard and just duct tape it together, but who knows, can't see it holding the sort of boost I really want to get into shoving down this thing. Never mind, let's see how it goes. Okay, it's time to make this out of aluminium 2mm sheet. What I've decided is I'm going to cut the bottom 70mm out of just flat. I'm going to weld it all together. So basically I'll make a box section 70mm high. But then I need to make these curves here, and I want to make them really precise. So nice curves, you know, not just roughed out and sort of approximate and fill in the gaps with filler rod. So what I've decided is to mount this in the chuck, mount it on the lathe, and clamp a bit of plate onto it using T-slot nuts and bolts and fasteners to clamp it here and here, and then just turn it in the lathe to make this inside diameter that I need. Do the same on the outside, so there'll be two pieces made, and then just once I've unbolted it, just make a cut to make this arc section that I need to weld on top of the 70mm bit at the bottom to make this side piece. So 70mm up, piece of this welded on top. That'll give me a very nice side plate. These top and bottom bits, or front and back as it is actually, I'm going to do the same thing. I'm going to put a piece of 2mm plate into the rollers and roll up a section that's a nice curve, and then just cut out the piece I want. So this is this inside bit's 50mm radius, 100mm diameter, and this one's 252 diameter. So fairly easy to do that in the roller, adjustable roller. So that's what I'm going to do. So progress reports as we go. Here's the plate mounted up in the lathe, ready to start making cuts. Now I have a problem figuring out the diameter of this, or the radius, take your pick, whatever, because there's no reference point. So what I've done is I've fitted this 14mm end flute into it, and I've made a little pass, and you can just see that it's made a mark here. So this is a 14mm cutter, it's just made a mark. So that point is a 14mm diameter circle, so I can use that to set the digitals to when my cutter is just touching here, I can set it to 14 mil, and then that's the reference for the inside. And then I'm just going to have to come up with something to measure there. Then it's, to do the outside one, it's just the difference between the inside and the outside, so that's easy. But to get it started, I needed a reference, and this 14 mil cutter is giving me that reference. Right, I'm making progress increasing the diameter of the inside arc. Now what I want to do is make sure that this arc is whatever the diameter is that it says here. Now what I've decided is to use this piece of scrap basically out of the bin, which I can easily measure the diameter of, 50.68 in this case, something like that, 50.54, 53. And I can just fit that in there. So that's a pretty good fit. So to me, this hole is, this arc here is the same diameter as this. So what I'm going to do is set this to whatever that diameter is, and then go from there. So it's just a test partway through to see progress. So it's about 0.3, 0.4 mil out. So yeah, and that'll be fine right through till the end of the job as far as I'm concerned. It's not critical as long as it's in the ballpark. I probably really don't even need to adjust it, but I'm going to. Okay, I've just done a quick check partway through the job. So this arc is 100 millimeter in diameter, and out to here is 80 millimeters. So that makes the radius the sum of the two, which is 180, which should give a full circle size of 360. So far it's working exactly as planned. I just need to take about another 40 odd mil off it and be sweet. Okay, so that was nearly a screw up. This is a really good example of measuring everything twice and then having to think about it and looking at how it looks versus what you think it might be. Now, this plate is 250 millimeter diameter, so clearly this disc is not 360 but more likely 260, which is right. So the radius here is 50 millimeters from this is approximately 80, give or take. So 50 plus 80 is 130 times 2, which is therefore the whole diameter, not the radius, is 260. So yes, I mean it was pretty obvious, but you for something less obvious it would have been fairly easy to make that mistake. Anyway, spotted it before it was a disaster. So this is the finished piece that the two pieces of arc will be cut from. So this is the leftovers from the cardboard one where I mocked it up, and you know, pretty well matches up, but this is precise. So this is 100 mil and this is whatever it is. So what I'm going to do is cut two pieces out. I'll stack them one on top of the other, and then machine the edges of both pieces at the same time so that they're identical amount of arc. Shouldn't be too hard to get it lined up. I've made a couple of scribes just before I removed it from the lathe, just to give me an idea when I'm rough cutting it, so that, you know, I've got an idea. But what I'll do is I'll actually machine up something that fits in here on the lathe. I'll clock up the mill on that piece I make up, and then just fit this onto it, or the two pieces onto it. So I'll know where the center is, because it'll be the center of this piece I've made up. These will be butted up against it, so the center of these arcs will be the center here, and then it's just a matter of offsetting half the diameter of the cutter and making a pass to get the edge, go back to center, offset half the diameter of the cutter the other way, and then cut the other side, and we'll get two perfect cuts that line up with the center. Cool.